urban warfare in the 21st century is even more complicated and difficult than it has ever been. To win, you must out-train your adversaries. Some ask, why can't we train as we fight? What if we could train more often? What if we could incorporate combined arms? We heard these people. Training for urban warfare just got more realistic, more accessible, more integrated. No more what ifs. We are 4GD.
To those of you joining us from the UK, good afternoon. And those of you joining us from the USA, good morning. And welcome to 4GD's launch event, Discovering the Future of Urban Training. My name is Rob Taylor, and this is my colleague James Crowley. And over the next 30 to 40 minutes, we're going to be taking you through what we believe is the cutting edge of dismounted close combat training technology. Principally, our two new products, Ecfectus, a dismounted close combat data collection and analysis system, and Acies, an integrated reality single synthetic training environment, both of which form part of the 4GD SmartFacility.
Before we start though, I'd just like to take a moment to remind you that if there are any questions throughout this presentation, please don't hesitate to email us at launch@4gd.co.uk and we'll answer these at the end. For those of you who don't know us, 4GD is a veteran-owned and operated training technology company. Our company was founded on a desire to blend military experience with the most modern technological expertise to drive operational excellence through making training more accessible, more targeted, and more efficient, putting the operator at the centre of the experience. In addition, we recognise that the technology now available presented us with the opportunity to make the aids and capabilities match the quality of the instructors and the people that we served with. Running a training serial shouldn't be as hard as completing a Rubik's Cube. The challenges we faced when doing this were not small. Soldiering is dynamic, visceral, and creates disorder. Technology is the opposite. The first challenge we faced was ensuring that everything we developed achieved what was possible now, while also improving it. While our initial goal was for a holistic virtual trainer, we very soon came to realise the fidelity of the entire simulation was still no match for real life. As an example, VR controllers looked and felt nothing like the rifle a soldier was actually carrying. Through our development, we went on to learn that there was a sweet spot between training requirements and technological capability, where we could use the synthetic world to replicate capabilities normally unavailable to troops, without compromising the fidelity of the fundamentals. We also learned that data was important, not just for performance tracking, but also for the quality of any simulation. In these two visualizations, you may have seen how we found that overlap between critical training requirement and technological capability. We believe that this approach will achieve immediate impact, whilst also keeping the path clear for regular upgrades and improvements. We also came to realise that a broader capability demanded greater availability. Soldiering is, and always will be, a degradable skill. To maximise performance, we needed to change CQB from a monthly to an hourly activity. Centralised training facilities did not offer the access a localised facility could. By improving the variability and quality of training, through design rigour and technology, we could decentralise urban training facilities and deliver meaningful capability at the point of need. This greatly increased both the amount and the tempo of training that was achievable. Having identified our terrain, we then considered the link between synthetic and physical and found we had to really reassess our understanding of space. What opportunities and constraints were presented when the environment can be both physical and synthetic? What is the interplay between the infinite virtual and the finite physical? In short, how do we shape our buildings when they're both real and virtual? To an extent, this can be addressed by expanding the physical. And to achieve this, we've engaged with a leading engineering consultancy to develop turnkey infrastructure solutions at any scale. However, thinking inside the box of the smart facility, we can use the synthetic to bring the outside inside and introduce synthetic combined arms into localized infrastructure. In this way, we create an urban training environment rather than a simple shoot house, which empowers its users. This environment also provides the perfect ecosystem for collecting and analysing objective data. We could be used for both targeted performance enhancement as well as act as the engine to drive our simulation. Finally, having decentralised training, we once again found that technology could be used to re-centralise it, meeting that initial test of achieving everything we can do today and more. In addition, collective training doesn't just mean greater numbers of the same unit. It means introducing snipers, mortars, UAS, and other combined arms. Acies provides us with the architecture to blend simulation from multiple sources. Conducting these serials synthetically and locally not only realises significant cost benefits, but also hugely increases the amount and range of training activity a unit is able to accomplish. An environment where it's safe to fail. Before we could set off on this mission though, we knew that we needed to look again at the basics and make sure that we were doing them well. In order to truly realise the potential of a decentralised training facility, we knew that the training space had to be changeable. Were it not, greater accessibility would mean the exercising troops very quickly learnt choreographed clearances and the most basic training value would be lost. Learning to fight the facility must become a thing of the past. This, in turn, led to the development of SimWall, the foundational element of the smart facility and the core of Level 1. SimWall is a reconfigurable panel system that allows exceptional variety. The average smart facility floor plate allows up to 4,000 potential configurations. Importantly, these do not all have to represent the inside of a building. With an appropriately sized facility, outdoor scenarios, including street scenes, can be generated with the floor plate. Easily movable, SimWall provides unprecedented variety. Alternately, a floor plate can be designed to meet a specific training objective, repeatedly and across multiple smart facilities. Intentionally non-ballistic, SimWall both encourages accessibility and ensures that training can be conducted without the constraints imposed by live fire danger areas. Level 2, 4GAV, is where the smart facility becomes intelligent. Made up of 3 core components. First, a video monitoring system which provides a nearly perfect top-down view of the whole training space, regardless of the configuration of Level 1. We know the importance of cross-threshold tactics and needed a system that allowed an intuitive view of the tactical flow. Next, a zonalised special effects suite, focused on generating background immersion as well as battle simulation. Finally, an intelligent facility management system, which controls these 2 components, as well as providing the technological foundations for the more advanced levels to come. 4JV has been designed with ease of use in mind, and our aspiration is to empower junior commanders to be able to run training themselves. Combined, Level 1 and 2 form the entry-level smart facility. We have Level 1 and 2 facilities already operational in both the UK and in the US. Levels 3 to 5 take this foundation and grow it to include data collection and simulation. Level 3 is our smart target tree, which we'll discuss next. Level 4 is Effectus, and Level 5 is Acies. Back to Level 3, Simstriker. This is the first of our new releases and a major component of Ecfectus. In any training environment, we knew an adversary was important. We also knew that in the training progression of force on target to force on force, that the target was lacking. We therefore looked at what a target should do, as well as what a target could do, that a live adversary couldn't. The result is Simstriker, an adversary that can shoot back. An adversary that when activated can verbally engage operators and react to noise and motion, and whose behaviours will be changeable based on need. It's also a target that can record hits from non-ballistic rounds, a target which collects data and that uses this data for analysis as well as to feed the Acies simulation. One of a kind, Simstriker is the future of non-ballistic targetry.
Data is the next stage in our journey. We know, as many do, the potential objective data has to offer, and we wanted to harness this to improve performance. The result of our data-led outlook and a number of years of development was Effectus, a system that, by aggregating data from a number of different sensors placed across the operator, their weapon and the SmartFacility, delivers potential greater than the sum of its parts. This meaningful objective data can be used in two ways. Firstly, Ecfectus data can be integrated back into the Acies simulation to generate immediate effect. Secondly, once a data threshold has been met, it has the potential to provide targeted feedback for analysis and learning afterwards. Ecfectus will not only give important insights into relative performance and improvement in the short term, but we believe it will allow the development of insights into the effectiveness of TTPs in the longer term. Effectus allows us to show outputs in real time for the instructor and assess the exercising troops after the event, facilitating assessment and competition between individuals and groups. These immediate outputs will be presented in the NATO measurement framework of lethality, survivability, mobility and sustainability. This feedback, however, is not the end state. The deeper analysis comes the more the system is used. By collecting the data, it allows us to simplify the important elements of behaviour and show them in a schematic view both during and post-event. We also provide an output to allow high-level assessment of performance at both individual and collective levels. This is a simple assessment of lethality, survivability, mobility and sustainability. These are simplified and limited versions of broader concepts and not definitive. As you look deeper, you see the basis for the score, in this case hits, incapacitations and kills, the definitions of which can be changed to match specific doctrine. Additionally, the information from each run-through can also be viewed in detail. This is a data output to help individuals and commanders see performance, but the underlying data is there to be analysed. The collection process is a scientifically robust approach to mission-led data collection to generate meaningful insight. Importantly, we can deliver immediate training value now, whilst also facilitating a real move towards fully metricated, fully understood small team training. When this data threshold has been met by a collaborative generation of the data, the foundations for deep understanding have been laid. We don't want to suggest we have all the answers now, but we do believe that we have the vehicle to get us there. This requirement for data threshold hints at an important point about the collection. The data must achieve both quality and quantity. The former is achieved by the sensors, the latter by the wearability. We have tried where possible to make our sensors unobtrusive and either a part of or like in-service equipment. Now to go through the constituent parts in more detail. It almost goes without saying that weapon handling is critical. When it is fired, where it is pointing, and how it is manipulated. The ARC sensor provides us with a range of weapon awareness data. Eye tracking. Tracking of where the head and eyes of the operator are orientated are important for training purposes, leaving aside later data analysis. Biometrics. Safety, fitness, and stress. We use body track sensors to give an understanding of key metrics. Ethical and data protection issues are important in all data collection, and particularly in physical data, and we are alive to the questions over ethical protocols. Finally, all this will be able to interface with a soldier's C2 and C4IS devices. To these body-worn sensors, we add inputs from the SmartFacility and Simstriker to complete the data picture. We realised quickly that all this data could be used to extend the simulation even further. Not just analysis, but what we now see as an input-output device for integrated realities. A game controller where you don't press any buttons, indeed where you don't even recognise the buttons are even there. Acies is a system which allows integration of real-world smart facilities in different geographic locations into the same synthetic exercise. It is a system which allows combined arms simulation in support of a real-world attack on an urban environment. It is a system that enables an infantry commander to communicate with a sniper to gain information and eliminate targets which then fall in the physical world. Acies and integrated reality is not just the future of dismounted close combat, but also of collective training. Before we begin, however, we thought it'd be useful to ensure we are using understood terminology. We decided to use the UK MOD's definitions, and apologies to those of you in the US. Their definitions are: live is real people in a real training environment, virtual, real people in a simulated training environment, and constructive, simulated people in a simulated environment. Industry define live the same as the MOD. They define virtual reality as an environment where digitally created content surrounds the user, typically through a headset. They define augmented reality as an environment where digitally created content is overlaid into the real world. And they define mixed reality as an environment where digitally created content is inserted into the real world. 4GD view simulation slightly differently. We view physical and live the same as industry and the MOD, but we view synthetic as any environment in which the user can view the synthetic battlefield, be it through a VR headset, or an augmented reality device, or even projection. Combined, these two form 4GD's integrated realities, a single synthetic environment where both physical and synthetic are present. Imagine shooting a target in the physical environment that then falls in a sniper's synthetic simulator, and conversely, a sniper's synthetic simulator target being hit that then is replicated by a target falling in the physical environment. Now we've covered definitions, we can start to look at the theory of Acies. One of the key weaknesses of in-service dismounted close combat facilities is the lack of training value for the commander. We want to change this, and so Acies, by creating the depth battle space, enables the dual training of the combat element in the close battle and the commander in the deep battle with the numerous combined arms assets available on the modern battlefield. To enable a thorough decentralization of training, these assets need to be replicated virtually, then controlled or targeted physically to encourage these commanders to become comfortable with the technological dimension of observation, orientation and decision making. Acies has been built to date in Unreal, however both the software and simulators, as will be seen later, are agnostic with defence programmes such as DVS in mind. As previously stated, 4GD believe users should focus on critical training gaps that can be overcome with near-horizon technology. Dismounted close combat is high fidelity but low cost. Combined arms is lower fidelity but much higher in cost. Therefore, we believe focusing on dismounted close combat with regards to synthetic may prove to be a costly method of enabling that which can be done simply, rather than focusing on areas where the cost saving will far outweigh the capital cost. To enable the accurate overlay between physical and synthetic, the data inputs in terms of tracking need to be down to the centimetre. This is why the relationship between Acies and Effectus is so fundamental to the performance of the smart facility. As mentioned previously, this video shows how the two environments are seamlessly stitched together. The Simstriker, or human enemy in the physical, is overlaid perfectly in the synthetic and then back again to create one truly integrated environment. We now start to look at how the smart facility can be configured to enable this high fidelity training. This is not an accurate look at the smart facility's architecture, but more representative of the different functions found within. The main training area, built around levels 1 and 2, is the heart of the smart facility, enabling high quality physical urban training whenever required. Operators in the physical space can see into the synthetic through real world portals such as ATAC. We have tried to ensure the visual connectivity between the different elements is as true to reality as possible. For example, a drone can see dismounted troops in reality, but dependent on the offset range, dismounted troops might not be able to see the drone. Rooms to the side house the various synthetic simulators required to create the integrated reality battlefield, and the various portals that enable synthetic to see physical. The first houses the passive iStar capability that, unmanned, can create the synthetic feed that commanders can view through their ATACs in the physical space and ISTAR simulators in the synthetic. The second represents direct fire simulators, such as this sniper simulator, through which the user can see the IR battlefield through a headset or projection. This enables an observation link from the synthetic into the physical. The third represent combined arms, on which we work with our partners D3A. D3A, like 4GD, is a veteran-owned and operated business who are an end-to-end training and simulation company. The capabilities that can be found in this space are a tactical forward observer simulator, viewed here, which allows users to look over the physical facility synthetically, then coordinate combined arms effects either independently or requested by commanders in the main physical training area. In addition, command capabilities can be placed into this area, enabling subunit to formation collective training, which will be covered later, to be conducted using real dismounted data inputs. To reiterate, the main space is physical, where troops can conduct high-quality, high-fidelity training and look out into the integrated synthetic battlefield through portals such as ATAC. The remainder of the space is synthetic, where users can look in to the battlefield using portals such as virtual reality and projection. These areas, shown in their physical smart facility location, are clearly redistributed in the synthetic smart facility integrated realities battlefield. The main training area, the largest in the physical, now becomes the small centre of the integrated reality battlefield. Then other elements are placed wherever they would be for real. This creation of space, where the depth battlefield becomes the much larger space, enables complex pre- and post-mission activity, such as approach work and offset BDA, for example, to be conducted in the normal battle rhythm. Imagine a 6-hour integrated exercise with a 1-hour physical component. What we have shown so far is how decentralized training using Acies in the smart facility can improve operational performance. What we are now going to show is how Acies can also synthetically co-locate facilities in order to improve collective training. As you see here, there is a smart facility operating in the north of England in both the synthetic and physical. Similarly, there is an identical facility in the south of England running independently. This geographic dislocation can be overcome by synthetic co-location, and the two environments can be placed into one single synthetic training environment, as you can see here, with the two geographically dispersed teams moving into the same synthetic battle space. To highlight the comment made earlier around command training, in this scenario, Team B is stopped from breaking the corner either by commander in their own team or Team A's commander looking at their ATACs, or a dislocated commander looking at an ISTAR wall in a synthetic operations room, spotting a sentry. The commander coordinates with the synthetic direct or indirect fire asset, in this case a sniper, who engages the enemy, removes the threat, and then communicates through to Team B that they can continue with their mission. One has to imagine that this synthetic link is made even more physical by gunfire in one facility, captured by Effectus, being heard over speakers in the other to make it sound like it is less than 100 metres away, as in the synthetic environment, rather than the 250 miles away it is physically. The scale of this synthetic co-location is only limited by the number of smart facilities specific users have. We have shown a direct fire synthetic asset or simulator in this example. However, as previously discussed and shown in the opening video, this could just as easily have been an indirect combined arms fire weapon, such as a mortar. Imagine the learning point here had indirect fire been used in such close proximity to Team B. What you've seen here is how we believe the smart facility can move from a physical platoon company capability into a synthetic battalion plus formation training capability. We believe this could be the future of collective training, enabling geographically dislocated troops to synthetically co-locate, thus improving the quality and frequency of training, while also increasing the harmony of the troops involved. Up to now, we have focused on the military. However, Acies can enable training in any operational environment or operation type, such as urban defence. As seen in this video, at the touch of a button, the environment can change from the kinetic military rural to a complex civil operation in a built-up area.
Thanks for sticking with us so far. I know we've covered a range of very complex capabilities today. I'd like to take a moment before moving into the Q&A to summarise these. So to go back over again, the SmartFacility. Level 1 is SimWall, the reconfigurable physical foundations of the SmartFacility. Level 2 is 4GAV, both the brains of the facility and the video monitoring system and special effects suite. Together, Level 1 and Level 2 form the foundations of the 4GD SmartFacility. Level 3 is Simstriker, the intelligent, hit-recording, non-ballistic target. Level 4 is Ecfectus, the data collection and analysis system. Level 5 is Acies, the integrated reality combined arms trainer that forms the capstone of the SmartFacility. As mentioned a moment ago, we're now going to move into the Q&A. I'd like to just take a moment to consolidate the final questions, and we'll be back to you with the Q&A.
Thanks very much for waiting. We've got a number of questions that James and myself will now do our best to answer. Starting with one from Tim in Yeovilton. Do you have to wear VR headsets to use the SmartFacility?
Yes, actually I'm glad someone asked this question because it's really worth clarifying. Inside the physical training space itself, no. The portal that we use to engage with the synthetic environment there is the TAC device. Outside of that though, when we consider combined arms, then yeah, there will be elements that have either VR headsets or other VR portals that are slightly more fixed. But we tried to be really conscious of the impact of the equipment that we were putting on the individual, certainly when it came to fighting through different parts of our facilities. And really when it comes to headsets, quite honestly, they get in the way of being able to hold your weapon properly. So we were looking for portals that gave us the opportunity to introduce a synthetic, but it didn't impact the individual soldier massively.
Great. To what degree will Effectus be built on open software architecture, and how will the user be able to access their own data? That's from Dan in Australia. I think I'll grab that one. So I'll start off with the second half of the question, which is the access of data. So the Effectus UI has been designed to be accessed at a number of different levels throughout the command chain, be it at the sort of senior level, looking at sort of operational capability, right down to the individual and sort of the subcategories of how they're performing. How that will be accessed is going to be down to the end user, be it a tablet with the individuals, be it a tablet on the facility, or maybe be a tablet at the sort of headquarters where people can go in and access the data. In terms of the first part of the question, we've taken in mind the sort of rapid development in technology at the moment. So in terms of open software architecture, yes, we've built it with an ability to integrate with developments and new technologies as they sort of emerge over the next few years. Got anything to add to that?
No, I think that's good.
Cool. Next one was, where are Ecfectus and Acies in terms of TRL? And I'll probably grab that one again. So level 1 and level 2, as James described earlier, which are the sort of forming blocks of the SmartFacility, are at TRL 9, and as we sort of as we articulated in the presentation, are in use both in the US and the UK. The smart target tree, we're aiming for be TRL 9 by Q3 this year, and level 4 and level 5, Effectus and Acies, are somewhere between a TRL 6 and a 7, and we're currently in a rapid development process, but clearly to get to TRL 9, that needs to get rolled out into the operational training estate, and clearly that is over to the end user. But yeah, we are as ready as we can be at this point to roll that into the estate. Next question is one from Sam in Boston, which is, who are you working with in the US?
Okay, I'll take that one. So we've got a couple of end users in US SOCOM, as hopefully you will have picked up as we've gone through the presentation, and as Rob alluded to then. In terms of representation and how we actually approach the US, we have a partnership with a company called Mountain Horse Solutions. who really act as our foot on the ground over in America. It's quite a good question though, and I did see a couple of others come in as we're going through about where else we fit globally. So it's worth just taking the opportunity, if you don't mind, to mention we have representation in Australia with Danger Solutions. We have representation in the Far East with a company called Nitor, and we're working with those guys on some really exciting opportunities as well. But based in the UK, it's directly us. But yeah, we've got a bit of a spread internationally.
Great. We currently have various in-service simulators at our unit. Can these be integrated into the SmartFacility? So as I discussed earlier in the presentation, through our work with our partner D3A, we are already working with some in-service simulators and some simulators that are not in service. The intent with SmartFacility is clearly to create that totally combined integrated reality battlefield. We can integrate various simulators throughout the estate. So yes, the answer to the question is sort of a resounding yes. Anything to add to that one?
No, I mean, I'd say, yeah, very simply it is a yes. Obviously, actually achieving that is really quite complicated. So whilst in theory we absolutely can, there are some steps we need to take to be able to make sure that's really at the level that we want to, which is why things like the work we're doing with D3A is so important, because it really sets us off on the right foot to be able to achieve that.
Fantastic. And then obviously there's always one, so I should answer it. William Basingstoke asked, if I wash my socks now, will they be dry tomorrow? And I suppose the answer will be whatever drying cycle you use, Woody. So there's your answer to that. So I think that sort of ends the Q&A for now. If there are any questions when this session ends, please do email us at launch@4gd.co.uk to ask any further questions and sort of organise any further meetings you'd like to have.
Yeah, I would say as well, we noticed a few come in just as we were getting back on screen. And just to make sure, we'll try our best to answer those ones because we didn't get a chance really to look at those and read them properly before coming back on. So we'll try and approach those after the event.
Great. Before I say goodbye, I just want to thank our various partners, specifically UTM, Vitopia, but also Brigantes, for whom their equipment sort of features so heavily in our filming. To those of you in the US, I hope you enjoy the rest of your day. And those of you in the UK, have a lovely afternoon and evening. And thank you very much for watching the 4GD launch event on the future of urban training.